What's up? Welcome back, everybody. Today we are working on my video editor. So the pitch is I stream for fun, right? I'm streaming as a mechanism to make sure that I keep making slow, consistent progress on projects, right? It prevents me from working way too much on something because I don't want stream to miss stuff, which means that I won't work like 16 hours a day on something and burn myself out. But it does mean that I want to make progress every day. I have to hit the go live button, so I have to keep making progress on my projects. And a side effect of streaming is that, maybe other people will see what we're doing and maybe they'll like it, right? And so I wanted to upload videos to YouTube, but the content is pretty long for YouTube. 2-hour chunks is a little bit much. And it'd be nice to have the freedom to go a little bit longer on Twitch if I feel like it, and maybe cut down a VOD into something that's shorter that YouTubers will still have their attention grabbed with. So I wanted to experiment with, is this type of content something that we can cut down into shorter segments? And I tried doing that with KDN Live, video editor on Linux, and I was like, holy, this is going to take forever, easily 4 hours for a 2-hour video to be cut down. And it's if the point of this is for me to have fun coding, then why am I spending more time on video editing that I care way less about, right? And so here we are. It's we can write tools to make our lives easier. And so what I'm thinking is I can read way faster than I can watch videos. So what if we were to create a video editor that's based around the idea of selecting text, right? So if we were to generate subtitles for a video using some sort of neural network, OpenAI Whisper is what I'm thinking right now, we could show these in the corner of our video editor, and maybe you could select this text and use that to create segments, right? You could say oh, I want this stuff in the video, this stuff I don't care about. And maybe you could get through something way quicker, right? So I'm thinking the timeline, you have your typical timeline in a video editor. And maybe you would have this cursor in the text that kind of follows along with that. And maybe you could select text and tag it, and then it would put little handlebars in the editor that you could, or in the timeline at the bottom, that you could kind of jiggle around if you want to tweak kind of where things are clipped a little bit. And then I want it to be able to export video, etc., whatever, right? And so where we're at today is we have the ability to play a video. So this is using OpenGL. We open up a window, we get an OpenGL context, we ask FFmpeg for some data to display. He gives us some YUV encoded frames. We put those into a texture, shove them into the OpenGL world, when we have a fragment shader that converts that YUV data into RGB data. Great. We also have this sample audio playback. So I don't know if you guys can really hear that, but it's just playing a sine wave for a small amount of time. And today what I want to work on is actually getting the audio out of our video that we're playing, and instead of playing a sine wave, play the audio that comes in. So we're gonna have to extract stream info from our video decoder interface right now. We don't really have the ability to say what do you have in there, video? What do you have in there? What we do instead is we ask for individual frames, and we might get an audio frame. And so what we want to be able to do is we want to say before we even try to get any audio, we need to configure our audio device what is available for us. Then we have to actually set up the audio device to match the stream parameters. So if the video says I'm 2-channel 48,000 hertz float data, we need to say, okay, well, when we upload to our audio device, can you be set up as 48,000 hertz 2-channel whatever I said, float data? And he goes yep, sure can. And we're okay, cool. Then we needed some way to get the data into the audio thread. So the way that this audio library works that we're working with is he spawns a thread. The system will on that thread call into us and say hey, do you have data for me? And we go yep, here you go, here's some data. And then he'll continue doing audio things over there. So we need a way to get from our decoded audio frames into the callback. We need to make sure that we can't just do that callback on our normal decoding thread, because it's very, very, very time sensitive, right? So that's why it's on its own thread, and so we need a way to get the data over there without blocking it. Then we feed frames there, and then AV sync I think is going to be pretty interesting. So how do we make sure that what if we ask the audio thread to work at 48,000 hertz, but it works like 48,002 hertz. What happens there? Is over a 2-hour video, are we going to get like significant drift? I don't know, right? So let's think about, like, we have to think about how are we going to handle the case where the audio and video are moving at different speeds. You know, what happens if our audio thread gets blocked up for a second because our disk gets used, and every fucking operating system just like loses its goddamn mind if your disk is in use, because it's like, oh, I can't use my CPU, the disk is busy, what do you want from me? And so, like, let's just see if we can like work through those cases and try to make sure that, like, at the very least, when frames are dropped, that like the video thread will like drop to let itself catch up, or maybe we'll like reshuffle audio, we'll skip some frames, I don't know, we'll figure it out. But we need to make sure that like when one thing gets blocked, everything gets blocked. Hand wavy. Okay, so I think that's enough context to get us going. And I think the first thing that we need to do is just like ask our decoder interface, hey dude, what's in there? Will you write your own AV engine or just use FFmpeg to do all the processing in general? I think that FFmpeg is going to do everything. I don't think that I'm going to I don't think there's any reason for me to go beyond that. It's not out of the question, but I just don't see why I don't see a reason to do it right now, right? Sometimes you use a library and it doesn't like really provide you what you need. And I think that in this case, the project has enough scope that there's no reason to just take on stuff for no reason. And FFmpeg seems pretty goddamn flexible. So we will see. Okay, so we are going to say, hey, buddy, what do you have for us? And so he's probably, I guess, going to give us back like a stream iterator, I guess, right? He could give us back like a vector, like, you know, vector of streams, but this is Zigland, and so it's easier to work with iterators because you don't have to worry about like allocating something here and asking your caller to deallocate it. If you work with an iterator, then he'll just like spit out values lazily, and the caller can decide that he wants to push them somewhere if he wants to. So here, I guess we'll have some stream iterator, and I don't really know what it's going to do yet, but it will become apparent pretty quickly. So if I remember correctly, when we initialize our... Am I in the wrong spot? I totally am. I'm in the audio section. I want to be in our decoder section. I don't know what I was thinking. Decoder. Hi, new here. Why is there this maze animation over your head? Well, you see, because Zoomers don't have any attention span, right? You have these, like, TikTok is already out. Big hit, and these like 30-second videos, they're already too short. You gotta throw Subway Surfers on the bottom, you gotta throw Family Guy clips while somebody else is talking about something else, right? And so the maze is a way to like keep our stupid little ADHD brains a little bit occupied. Some people hate it. I personally, when I watch them back, find it very helpful. Like, I just like stare at it and I'm like, ooh, nice maze now. But I can see some people don't like it, and I can see why. But it's just a choice that we've made. Okay, so this guy is where we're going to have this stream ID iterator. So we're going to have maybe this will go out here. Maybe, I don't know. Pub const stream iterator is equal to some struct. And who knows what he's going to do? Who knows? Then we need to make our little function. So pub function streams, and he's going to take in a video decoder and return a stream IT. I don't know if he's going to be failable. Maybe he is. Who knows? We'll figure it out. And when we construct this guy, we have this like format context from FFmpeg, where I don't really know what format context versus it like really means, but as far as I can tell, this is like information about the container that we're working with, right? So you're gonna have like some MKV, and it's gonna have like, you know, an H.264 video stream, and he's gonna have like, you know, some like MP3 audio stream or something, and this is gonna be handled by some like H.264 codec. And this is going to be handled by like some MP3 codec. And so this guy is like the container level, and then you have like codecs for the individual streams. So if we want to extract info about each of the streams, I think we look at this guy. So we can say somewhere we have a format context stashed. So we can say self format context, and then I guess what's actually going to happen is we're going to inject that into the iterator. So we're probably going to stash the format context here. Format context, and then we're going to have like our iterator index somewhere, and then presumably we're going to have some sort of function next who takes in our like stream iterator. and returns something, like some output. And I guess that output will sometimes not be there when we get to the end of the loop. And we'll have to figure out what to do at that point. So he's going to be some sort of struct. And I guess maybe he's going to be a union, actually. Because a stream may be a audio stream or a video stream. I guess maybe could be some like shared data between them, but maybe not. I guess like at the very least the stream ID will be shared, but I think everything else will be pretty unique. So our video frame has a width and a height and a stride, and I don't know if there's anything really like setup we really need to do on video side. When we render in OpenGL, we kind of just say like, hey, we have this frame and it's this size, and we'll try to like shove that into our current window. And if the video were to change size, I don't think that would actually matter. Like if every frame in our video just had a different aspect ratio, we would just keep fitting it to the screen, which would look really weird, but it would work fine. Audio, on the other hand, is a little trickier, where we need to reconfigure our audio device or resample the audio to inject it into the device. So I guess here we'll just say that video is just going to be a struct that all he has is a stream ID, and audio will be a little more interesting. And I guess maybe maybe we will pull out the stuff we currently have in our audio frame into a new struct. So audio stream info or something. And we'll just take kind of like this stuff out. So the stream ID, the format, the number of samples, the channel data. And then in here we can say that we have like info, and this is just going to have audio stream info in here. Channel data doesn't go in here. Channel data is like samples, so it's only this stuff. And then down here in our iterator, our audio guy will return a audio stream info. There we go. Okay. So now somewhere in here we've already kind of peeked at the stream stuff. It's here. So we can say self format ctx at self I. We are going to say if self I is greater than something, self format context ctx number streams, maybe? Return all. Well, we'll see if that's right later, but I think it is. Then after that we can say, hey, after this iteration of the loop, increment I by 1. Then we can look at the stream, and we're gonna have to do something with it. So I guess it depends on the type, which I think we've seen in here. Let's see, ffmpeg, what is this thing called? A format context, AV format context. Let's see what's in here. Instead of just guessing, we can just look at the docs. You can look at the docs. NV streams is right. And then in the stream, we have its ID. So, and this is going to be a usize, and I think we have this like cint to usize thing already. So here we're going to say, what is this thing called? Stream ID. What am I doing? What am I doing? It's here. Cint to usize this, and then we'll say stream ID here. That's its purpose. And here we will try this, which means that this guy is failable, right? In theory, they could give us like a negative index into this thing, and we'd be like, what the fuck do we do with that? So I guess we'll have a little try here. No big deal. Good afternoon. Good afternoon. Shouldn't video input info include at least frame rate? Well, what we're doing right now is we extract, we like just read the next video frame and we check the timestamp on it. And then we say, if the timestamp is greater than the amount of time we've been playing, then swap the frame in. So like theoretically frame rate doesn't even really matter because like if the frame rate was variable, we would also handle that fine. And we don't have to do any like initial setup from that. So I'm not really like maybe if we wanted to like display this in like an info panel somewhere, then maybe that would be useful. But for now, at the very least for our usage of just playing things back, I think we don't need it. So we can save that for another day. Okay, so here we need to switch on our stream type. So I think somewhere in here it tells us the type of the stream. AV class index. I remember seeing like a type thing somewhere. Video. Here. Codec type. Oh, gross. So we get a stream. We then probably open a codec for the stream somewhere in here. Make decoder context is probably where we go. So we look over our streams. Oh, and so there's stream info. Oh, we populate the stream info in the format context. Okay. Then we go over each stream. And the stream has codec parameters. Okay, what's in there? What is in here? Codec parameters, codec type. So this should be able to tell us if it's audio or video. Yeah. So we'll look at the stream codec par. I lost it. Par codec type. Yeah. And if it is AV media type video, we're going to do one thing. What is it in this language? An arrow? Yes. And if it's audio, we're going to do something else. And otherwise, we're going to say, hey, unexpected or unhandled stream codec type, and we'll maybe even write it down. And then I guess in this case, we don't actually have to like fully error out. We can just return null. Like say, hey, oh no, we can't return null. Interesting. We actually can't return null. So maybe we'll say unknown here. Mason, thanks for the prime. Appreciate it. Because if we return null, it'll stop iterating. So here we can just return unknown. And then I think you have to put this here, probably. Like this? Probably? I don't know. Maybe like this? It seems to like that better. But I don't. This feels more correct to me. I guess we'll see. And then here we need to write down the codec type. So maybe here we'll pull this out. Codec type is equal to this shit. And then we say codec type here, and then we write codec type over here. Bing, bang, boom. Let's see how fucked up this is. Unused function parameter self in streams. Oh, okay, so whoever's returning this guy needs to return format context is equal to self, format context, and dot I equals 0. The error log is borked. Yeah, it does look like fucked up syntax highlighting because I forgot to close the quote in the right spot. It's a little better. AV format content does not exist. Where did I write that? Here. Oh, I must have accidentally deleted a character or something because that shouldn't be like that. No field name stream ID in audio frame. So this is at 365. I pulled out that stream info stuff. So we just kind of throw this stuff here, and everything that went in there goes up like this. Boom, 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 boom. And we're back to building. But nobody's calling the stream iterator, so it's not actually compiling it. So here we'll just do something like for deck.streams. We'll say, oh no, we have to say var streams is equal to this, and then we'll say while stream.next, and we have to try this because it could fail, and this is streams.next. We will get a stream out of it, and then for now we'll just print it. just so that we get something to compile. And there we go. Okay, stream does not support field access. So that's at 130. Why not? Oh, because I have to manually dereference it. Sure. Because C pointers can be null, and so he's trying to say like, don't you have to tell me if you want me to segfault. You know? And then this has to be the same. So maybe what we'll do instead is we'll make this a C AV stream, and then I think that will kind of cast itself away. Okay, so AV media type video doesn't exist, which is kind of surprising. It's because it's AV media with no underscore. It's a hard life out here. No field stream ID down here at 149, and so here can we just say like unreachable or something, or okay, here we will return dot video is equal to this. And then here we will just say unreachable or something. And my indenting is kind of fucked up for some reason, so I'm just going to restart this and see if that helps. Zig build. Okay, so it builds. It's really good. Very nice. And let's just fix the formatting of whatever the fuck I typed there. Oh, it doesn't fix it for me. I have to do it myself. Fine. We'll do it ourselves. Yeah. Okay. Oh, weird. This is how it wants it formatted? That's very strange. Oh, maybe because I didn't put a comma here. Maybe if I could put a comma there, it'll... Yeah, that's much better. Much better. Okay. So in this case, we have to do something like audio. And we have to extract some info. So maybe we'll do this. Const codec par is codec params is equal to this. And then we can use this guy down here. So what's in this thing? Surely this codec parameters has the information we need. Maybe it doesn't. Frame rate, video delay, channel layout. Oh, channel layout, sample rate. Okay, yeah, wait, that's a lot. That gives us a lot of info. What do we need here? What do we need? Oh, we actually do need num channels here. We do need that, which means whoever fills out that audio data stuff needs to say this is channel data len, or items len, I guess. Okay. Kind of redundant data on that side, but no big dealio. So does he have the format? He has a channel layout. He has a sample rate. He does not seem to have the format data, which kind of sucks. Oh, int format maybe? Yeah, there we go. Okay. Nice. So here we can say codec params format. See all this. Num samples was codec params. It's not num samples. This actually isn't what I care about. This goes down here. I want sample rate. Okay. Yeah. So we put this back here, and this is sample rate. Is a probably U size question mark? If this is in hertz, that should be fine. So we'll do this. Boom, boom. So it should be sample rate. Sample rate. And what's the other thing? num channels. So here we're gonna do something with this channel layout. Oh, so it's just codec params. What was it? CH layout. Like this. Okay. Num channels is equal to num channels. Format is equal to. What is our format type? We have audio format, which only is like F32 right now, but and we have like a 2 mini audio format. Maybe we'll do a from. No, that will live in FFmpeg stuff. So I think we must already have this somewhere. Where do we construct our format here? Here. So here we can just split this out into a function that's like function FFmpeg format to audio format. And he's going to take in some int, I think. And he's going to return a audio format. And he is failable. And I guess we will give us a video decoder error, which is fine. That's a good enough error. And this is just going to be a return here. There we go. Yep. And then wherever we did this before, we'll just say try FFmpeg format to audio format. This. And then we can use that over here, wherever the fuck we were. Wherever we were trying to handle our stream iteration stuff. Yeah, here we go. FFmpeg format to audio format. And this will be try as well. Okay. Format equals format. Chillin. And sample rate is equal to sample rate. But then we need to do another one of these, like cint to usize. Like this. And we can need to say sample rate here. Num channels, I think we can do the same thing. Cint to usize. And we'll just say this is a number of channels. Boom. Probably it means try as well. We are not quite at compiling yet. So this guy, expected statement found this. Why? We switch on the thing. Switch on the thing. What is it complaining about? Expected statement? Is it because I have a comma here? Does it not like that? Does this guy need to be in squiggle brackets? Okay, I don't know what the fuck it was bitching about, but I think it's right now. We need to look at the sample rate. Did we not pull that out? Oh, this is in right, for each frame we also need to present the sample rate now because it's part of the info. For now I'm just gonna write undefined or 0 and we'll come back to this. Sample rate. Because we're not actually using that right now, it just is like a required field of the thing. So glad I found the stream after work when I can't code, I just watch you blast Zig. Nice, nice, thank you, thank you. I also like blasting Zig. That sounds wrong, but you know what I mean. Okay. So we should be able to run this thing now. And we do see that we get 2 streams out with like a reasonable set of information in them. So that's a pretty good sign. Pretty good sign. So now we have all the info that we need in order to configure the audio device. This should be, say, 29, not 39. A rare case where we're on track. A rare case. Okay. So I guess in our audio test, so those of you who have been following along, I did pull out like this like audio module, and he has like this audio player now, but all of the code is exactly the same as what we did on stream. It's just like I pulled it out of the main loop and shoved it into a class so that it would be easy for me to type const audio is equal to import audio.zig, and then we can construct our audio player. So we can say const. I guess we need to construct our player based off of the streams. And I guess theoretically there could be like multiple audio streams. And so I guess the question becomes, what do we do in that case, right? Because like if in OBS, you can record different things to different tracks. So like sometimes when I'm playing games, I'll record like game audio to one track and my mic to another track so that I can decide to strip out my mic if I feel like I just want to have gameplay. Or on Twitch, like some people will put their like music into like the second audio track, and then that gets stripped out of the VOD when it gets put onto Twitch later, because like there's like copyright rules or something. So in this scenario, we could have one of those cases, and the question is like, what do we do? And I guess for now, I'm just only going to take the first one. I think that's like a fine compromise for now, because like in our case, there is only one audio stream, and I don't want to deal with it. You know, later, if we have a GUI that's like set up, you could select which stream that you want to play, and then reconstruct the audio stream for each. I don't think you might want to have both playing, I guess. So maybe we would like put it like a checkbox and say like, okay, we'll construct these ones, but for now, one is good enough. So we'll kind of start, I guess, with this guy being a audio player, and we'll start him as null, sorry. Which language is this? Zig, not Rust. Not none, it's null. And we'll say that if we get a audio stream, we will check if audio player is null. Then well, I guess we actually we don't have to do anything with video. So right now we'll ignore video. We'll ignore unknown. Quack keyword. Which one is it? Oh, it's actually quite loud. I just have a like AI noise gate on it. I guess I shouldn't say AI. Some sort of neural network that is trying to look for speech only. Without that, it's actually like really bad. But it is a Durgod K320 maybe. I'm not gonna download LSUSP for this. It's not worth it. Not worth it. So I guess we'll say here we'll unconditionally break after the first audio stream, and we'll just put a comment here like, if multiple streams, we no UI for dealing with multiple streams. Video ignored. And we can come back to this in the future if we need to. And then here we'll say audio player is equal to audio player init with our params. So here we need our params, and I guess we just start looking at what does he need. Audio, we have our player. He has init params, which are these guys. So channels comes from params known channels. Format comes from params format, and sample rate comes from sample rate. Now, you could make an argument that it makes more sense for this stuff to just be, like, maybe we should just use the audio format info or stream info as our init params. And I would agree with that. I would agree with that argument. So reuse decoder audio stream params. I think that's fair. In fact, I'm not even going to put a fix me there. I'm just going to do it. We're just going to do it. Like that shoe company. So this is going to come over here. But this has stream ID in it, so it is slightly different. Never mind, I'm not going to just do this. But we'll leave the fix me in here and say maybe decoder, maybe reuse, and then put a question mark on it. Maybe reuse decoder audio stream params. Maybe. Who knows? Okay, and then this guy also needs an allocator. Which kind of indicates that we need to defer some freeing of this guy. So it's like, if audio player is not equal to null, audio player dnit. Something like that. No. Oh, because I have to. Oh, it's if audio player p like this. Yeah. Got some waves in chat. Hello. Oh, I was thinking the other day. I'm happy that you guys taught me about the little salute guy, the 07 in chat. I didn't know what this was, but he's like a little saluting guy. And then I was watching an Apex tournament, and there was a team named 07, and I got the joke. And I wouldn't have got it if you guys hadn't told me all about it. So, thanks, I guess. Okay. Let's log our audio player and see if he does something. Nope. So this guy needs to be try here. You just say, hey, please try to construct this guy. I guess really we could fail more gracefully here, but I don't want to. And then that just be a pointer, I guess. I think there's something about the audio callback thread needing a pointer to this guy. So I don't know if this is like a pattern that people do. I'm not like a huge fan of it, but I kind of say, hey, I'm going to heap allocate myself and give you back a pointer to it, because otherwise I can't register a callback. And then on dnit, I kind of like say, hey, look, like because I gave you back a pointer to myself, I also expect to free myself. But it doesn't really feel like, I feel like that might be like kind of surprising to people. But I guess I am people in this case, so get fucked. No field named dnit? I can see it. I jumped to definition. What is it complaining about? Do I have to do dot star here? I've never seen that before. Oh, oops, because, yeah, it's like this. That's why. It was a double pointer. It was confusing. Confusing. Classic double pointer. Okay, so if we run this guy now, we do have an audio player that does seem to be initialized in some way. I guess we don't really know, but at the very least, like maybe. We can't really test him until we do the rest, because right now the only thing that we can do is, oh, I guess we should, if we hit play here, we could maybe do a p.start, and then we should hear a sine wave coming in at 440 hertz. At least that indicates that the device would come up. I hear jack shit. I hear literally nothing. Which sucks. I kind of expected to hear something here. So I wonder why. Oh, it's because I have to do this after we initialize it. Derp derp, deep derp 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 derp. I see that pattern a lot. Oh, okay, nice. That's good to know. Okay, so we at least hear a sine wave. And I don't know if there's any way to like check. I'm just gonna mute this for you guys. I think there was like PW top or something. Can we see what's happening here from our video editor? He does say 48,000, but I don't really know. I guess it's really unclear, super unclear. So I guess we'll just keep going and just assume that that's right. I guess, okay, the next thing that we have to do is design API for frame passing. So the way that this works right now is in our audio zig. When we construct our device, I think, where do we use this callback? We use it somewhere. Ah, yeah, so when we construct our device, we use like device config, who passes in this function pointer to this callback function. And all this guy is doing right now is he's just like running a sine wave into the output. And he's called from the audio thread. We need to have some sort of API on here that will like pass frames off to the audio thread and maybe give them back, right? I'm not really sure yet. Let's think about this. So I think the way we have this right now is we have our like decoder, and he has like a frame pool, a bunch of like heap allocated frames of like, they might be audio and they might be video. In main, we like ask this guy for frames, and so he's going to like extract a guy from the pool and send him over here. Main. And these guys store a reference to the frame pool that allows them to like return themselves to the pool from anywhere. Mutex locked, so it's like safe. Now, I was thinking about this, and the frame pool does actually mutex lock for like 3 allocations at once. So that could actually be enough to slow down the audio thread. I don't know how high performance it needs to be, but it's something to worry about a little bit. We could maybe, there's a way to dodge that, but for now we're just gonna like leave it that way, I think. Then this is kind of all on like one thread. And then we have like, on this thread, we have our player, our audio player, we'll call him AP. But he's kind of like connected to, we'll kind of say that he kind of straddles the thread boundary. Because he's got data that is like kind of accessible from both of these guys. But yeah, he's just got data that's accessible from both. Maybe he shouldn't, but that's the way it is right now. And then we have like audio callback. So I guess we're kind of saying that we need some way to get this like this audio data into here safely so that it can be used from here safely. And so I kind of, even though we're not in Rust anymore, I really, really like the way that Rust forced you to write threaded code, right? Like when I used to work in C++ at work, like these like mega classes that were used for multiple threads were pretty common, and I don't really like it. What makes more sense to me is if we have some sort of like handoff mechanism. So maybe we should do something like, you know, this guy comes over here. We have audio thread only here, and then we'll have like specifically like a channel where audio frames go in and audio frames come out. And then things that I want to do here is for audio video sync, we almost certainly need to know which frames have been consumed by this thread. So maybe what we'll do for now, I think that there's a good chance that I'm going to want to like another channel that sends them back and lets them be freed from over here. But for now, let's just say that we'll send the frame over here. He'll like de-init, put himself back in the frame pool over here. And maybe we can check where the audio thread is by kind of seeing like what is like the latest thing in this channel. That's kind of what I'm thinking. So we'll have like, you know, we'll queue up like 5 audio frames or something in here, and we'll just be like, what's the timestamp of this one? This is the next one he's going to look at. Which kind of means that we probably want some sort of like ring buffer here, or like some form of queue. Ring buffer, maybe. I guess maybe it's not even like a ring. It's just kind of like something that you can push and pop to. So we kind of want something that's like, you know, stuff goes in, stuff goes out. But with the constraints that we want to make sure that we're not blocking too heavily, because audio thread high performance, probably, I'm assuming, unless the audio thread is asking for things way before it needs it. But I would imagine that if you want low latency audio, the lower the less buffering you have, like the better, right? If I were to have like a second of buffering and then I like give it some audio and then like play a video frame at the same time, we either need to know that we're a second ahead or try to get as close to the when we give it to the system as possible. I actually don't know. We should actually check that. Does this have some sort of like latency? There is. Oh, that's resampler though. Get output on get output latency are called, this is on resamplers. I want to know if there's like pulse audio. Okay, so low latency mode will be disabled, blah blah blah. Is there a way for us to know, like, extract latency? Low level API. Maybe the assumption is that it's just fucking soon. We could maybe look at the MA device structure and see if it provides anything. So you look at like a struct MA device. Struct MA device. Hello, where is it? Here. No, that's the config. Here. Does anything in here? There's like resample stuff. We're not doing any resampling. Playback. Do any of these things look like? Oh, this looks kind of like latency. Internal periods size in frames. Intermediary buffer len seems fixed size buffer callbacks. Oh, maybe not. Maybe this is like only for pushing and popping data, but it's like consumed immediately. Can we look for like the pulse audio implementation and see if we can like... Well, what we could do is we could look for the pulse audio API. Surely it has that. Pulse audio get latency. Latency control. So you are writing an application, want to control the latency pulse audio provides for it. I like it when people talk to me like, whatever this is. Okay, so make sure your timer's in timer scheduling mode, blah, blah, blah. Is there anywhere where we can ask it what the latency is? Buffer atter. PA stream, connect playback. Buffer atter. It must be like buffer atter. Okay, so they use this. Where is this? This is in device init. MA get bytes per frame. Here, yeah, I don't really see get buffer atter. Where is this used? Atter. Yeah, it doesn't really... Oh, period size and frame. This looks like what we're looking at, right? If this guy's claiming, without really reading, he's kind of saying that this buffer atter parameter is related to latency control. And then here he's saying period size and frames is related to this. So this guy must be... Yeah. Number of PCM frames per process. Notice that this will not necessarily be equal to what you requested, blah, blah. Period size and frames are just device config hints, not necessarily what you must, blah, blah, blah. Okay. Dang. The backend should inspect both these variables. Well, it's not input. Desired size of a period. Yeah, okay. So we could maybe... Yeah. The value affects latency. See below for details. Ah, okay. So there is something in here about that stuff. So we'll note that for now, but I think that we'll still kind of use the assumption that the latency will be low. At least low-ish. And we still do want to see this buffer from both sides, right? So on the audio thread, we're going to be popping this guy, and on the main thread, we're going to look at him and say, which one is it? Then on the main thread, we'll be putting stuff in here. And what happens if we put a lot of stuff in at once? Probably just dropping frames makes sense. I'm fine with that. No, we just won't feed it anymore. That seems reasonable. So we'll do something in our main loop like try push frame or something. And let's see, where do I want this to go? I kind of like dinit to live near init. I kind of want push frame to be separate from start and stop control. So maybe it being down here is reasonable. And we're gonna have to have something to push. So probably it's this audio frame. How do I want to handle this? So there are like two options here. One is that we can like import this decoder type and use it here, and the other is that we could like abstract it away and try to say like, hey, I am an audio player and I have these types. I'm a decoder and I have these types, and like make it up to our caller to glue us together. Which kind of like makes for better isolation sometimes. It makes it easier sometimes to swap out one thing for another thing. But I think in this case, I'm just going to say we're going to use the auto frame from the other guy. So here we're going to say const audio frame is equal to import decoder.zig, which kind of means we can actually say decoder here. And const audio frame is equal to decoder audio frame. Okay. Now, for now, this guy can maybe... he's going to have to indicate to us whether or not the frame was consumed. So maybe we're actually going to do this. Maybe we'll ask it, we can ask it, how many frames do you need? That seems kind of reasonable, maybe. Frames needed. Num frames needed. And he's going to tell us, hey, I need 10 frames. Please give them to me. For now, we'll just hardcode this to 0 so that we have like our API kind of flushed out. And here we'll say, just unref this stuff for now. Why is he mad about unused function parameters? I've stubbed them out. He must just be behind on compilation, maybe. So in main, then, we're going to do something like in our main loop. Right now, we say get next video frame. How do I want to handle this? I guess we could make a bit of an assumption that audio and video frames will be kind of like tied together a little bit, right? Like we can probably make the assumption that we're not going to get like 100 seconds of audio before we get like 1 second of video. I think that we should assume that they come in like somewhat reasonable order. So maybe what we're going to do though is we're going to say, hey, FFmpeg, could you decode me some data? And if we're trying to buffer to make sure that we like don't run out of frames to give to the audio system, then we're going to need to like write down our video frames. Or we can, for now, just insert till the next video frame, which isn't great, but maybe it's good enough. So that's going to be something like maybe we put the audio system in here for now. And here we'll just say audio player push frame AF. And then we'll do something like assert that the player num frames needed is greater than 0. Just to make sure that we always get stuff in. Because I do want to make sure, like, later, it seems reasonable to me that we will want to, like, queue things up, but I want to get somewhere first. Okay. Okay, so here at 156, he's expecting a semicolon, not a full colon, only a bit of a colon. And then when we call this guy, we are going to feed the player. So this has to come down like here or something. Yeah. Sure. It's not perfect, but it'll have to do. It'll have to do. He doesn't like that the audio player might not be initialized, so we're going to, when we initialize him, say that this is the optional version. This stuff actually should go even farther. This should go like down here. Here we will say var audio player is equal to audio player opt or else. I guess we'll log an error and say no audio streams. I think it's okay to not have audio streams, I guess. That seems legal to me. It should still work if there's no audio. Okay. So then in that case, our get next video frame just has to take in this thing, which is going to be a question star this thing, and then we'll say if audio player exists. I guess we can assume here that it has to be. It has to exist. Because we wouldn't get an audio frame if there was no audio player to play on. So we'll just kind of shove it in there. And then we can do the same thing here. Let's try that. Let's try that. Num frames needed. I guess that needs a little question mark on them as well. All right. And is it... Nothing is going so terribly wrong that it is crashing, so we're in a good spot there. And now I think it makes sense for this guy to use a thread safe circular buffer to get stuff in there. And I think that there's nothing that's like... let's see. There's the Zig standard library. I guess they have the like linear FIFO, which is maybe close enough. It seems like a lot for what I want, but maybe it's not the end of the world. Maybe we'll just use this. So we'll call this like a frame queue. And I guess we'll say that we are feeding stuff in here now. I was going to make a circular buffer, but then I changed my mind just now, so, you know, we'll deal. So I guess we'll say, like, const frame queue is a std FIFO linear FIFO using audio frames and buffer type of static seems fine. Seems fine. So now we have to say it's like what this static equals like 10 frames or something. So this is going to be a frame queue. So maybe put this here or something. I don't know how this works. And then when we initialize this guy, we have to make him. So we'll say const frame Q is equal to frame Q init. Is that it? Init static. Yep, seems fine. And then we just leave it in here. Now we need to mutex lock this guy because I'm assuming he's not thread safe. He could be, but I'm assuming he's not. Yep. So let's give him a little frame Q mutex is a stood thread mutex. Like this. Boom, boom. And then when we push a frame, we are going to lock the mutex. Defer unlock. And then we just push it. Read item, write item. Here we go. I guess this is failable, probably. Almost certainly. It's always failable. Yep. And that means this is failable. Chillin'. Chillin'. And then over here, num frames needed is going to be related to this guy in some way. So, this guy must have a, like, remaining space thing in him. Writable length. Yeah. Returns number of items available in the FIFO. Calling it number of items available in the FIFO seems strange to me. It's like the number of items that are not available in the FIFO. The amount of space left, but I think that's fine. I think it's fine. So here we'll say return self frame Q writable length. And we also need to lock our mutex, so flap that in here. Do you need to do some memory barrier as well? I'm pretty sure that the mutexes should produce a memory barrier for us. It would be a pretty useless construct if it didn't. Yeah, I'm pretty sure. Because I think that usually they... Well, I guess they could be implemented as like a semaphore with a relaxed atomic. But surely. This certainly just calls into Linux Vutex. Which I don't know what the guarantees are, but I'm pretty sure that it's going to put a fence in there for us. Like, in the kernel. Right? Because, like, the kernel is responsible for scheduling, and so he knows, he can actually make the decision in the kernel, like, oh, I know that I'm switching threads right now, so and when he's switching threads, he already has to, like, there's nothing to happen. Yeah, I'm pretty sure. Pretty sure. Because, yeah, what happens here is, like, what? We go to do a syscall, it's like, hey, I want this mutex. And if we need to lock, or if we're, like, contending, if there's contention, we sleep. It'll, like, reschedule some other process. And if it's not... If there's no contention, then he just keeps going, and we can assume that if there's no contention, the other writes from the other thread have already happened, and the fences are just for ordering of writes within that thread. And the unlock must already... It must be fenced. It must be. Right? Because you... Like, the only reason that you would need a fence is if, like, you could somehow reorder the unlock with other instructions, and surely that's not possible. So, I think it's fine. I think it's fine. Okay, so now on this side, we need to pull a frame. So, we'll do this in, like, a scope. Or maybe we'll do something, like, function pop frame. Who's going to return a audio frame. I guess maybe he will try to return an audio frame. Maybe there won't be one ready for him, and we're going to have to handle that. So he's going to lock the mutex, and he's going to say, hey, could I read item? And there we go. Then from our callback, we can say self pop frame. And then it's actually for 0 to frame count. We're going to... Oh, this is a little tricky, actually. This is a little tricky. Because what if the frame... There are like 3 cases here. Frame is too small. We need to push multiple frames. We need to pop multiple frames. Frame is too big. We need to stash remaining segment of frame for later. And frame is perfect. Copy whole thing. And then there's also frame is null, in which case we have to fill buffer with zeros, I guess. Okay. So maybe what we'll do actually is we'll say frame samples used. And this will start at 0. And what we will do, I guess maybe this doesn't need to be mutex locked. Maybe over here we will, it would be kind of nice to flag which things are expected to be used from the callback thread and which things are not. So maybe we'll do something like thread data is like this. And then this actually should have been in there. Yeah, and then we can actually even say like share data too, just to make things really clear. I like that. So with this stuff goes in the shared data. This goes in thread data. And then this stuff is usable directly. I like that, I think. Because then we can just say here, shared is shared data. And thread private is thread data. And that way, if we use this from outside the callback thread, it's like, oh, don't do that. And if we use this, we need to know, like, oh, lock the mutex. Am I mistaken in thinking you can only do acquire release on only given memory locations? Okay. So I think mutexes are kind of like a higher level API, but acquire release in atomics. I think that the atomics are, you have grain of salt, right? Because this stuff is hard and I could be wrong. Usually they have like the C++ memory model, which I think is used by like copied by Rust and Zig. They have like atomic int, and he is just like some location in memory. You can access this guy through like relaxed, acquire, release, and like super sequential. And so if I understand this correctly, this means like all other memory is undefined, right? Like, so it can be reordered with respect to other things. So if you have like, write some memory and then like read atomic int with relaxed, and then like other thread does like write atomic, this should be write atomic int, I guess. That should be read atomic int, then read some memory. So in this setup, if it's relaxed, you have no guarantee that these things are going to happen in the right order. Because the compiler or like your CPU might decide to like swap them around, right? It doesn't really care. If you say release here, if you have like other stuff down here, it's free to put the other stuff before or after, but it's not free to move this right down here. Because release is saying like everything before me has to fucking happen first. Don't fucking reorder it. And then the read is just the same thing but the other way. And syst is like uber, like don't move other stuff either. And so like the atomicness is like kind of just saying like don't reorder my shit. And then once these things get written into memory, I get a little flaky here, but I think it gets written into like your CPU cache. And if I remember correctly, there's this like buffer in that's called like the load store buffer, because things don't even necessarily immediately go to cache. They say like, hey, I have this thing in this register, could you like write this to the cache please, or something. Or then like maybe the buffer is like, could you write the stuff in the cache to memory or something. And so I think what happens is like your CPUs are looking at each other's, like they're writing down like, oh, CPU 1 said he was going to write this variable, so I have to wait for that cache to flush before I look at it. But like the atomics don't actually influence the like memory interface, like the cache to memory thing between CPUs, just that within one CPU we don't reorder shit, if I remember correctly. That's all like just like my internal mental model, and there could be wrong, but that's my understanding. How would one implement an atomic int? I think that like you have like x86 instructions or ARM instructions provided by the CPU, and you just have to like drop to assembly and call the instructions that the CPU docs say to use. And I think that there's something about like maybe on x86 the constraints are already a little like automatically set, but on ARM they're not. Something like that. I don't remember. But yeah, I mean, and then there's also like compare exchange stuff that I think that some things, I think those are implemented at CPU instruction level as well, but I'm not 100% sure on that either. When you say within a CPU, you mean like a logical core, yeah? I mean like whoever shares an L1 cache. So I think that like that might be a physical core, not a logical core. I can't remember. But yeah, I did mean like however we go cache to memory so that multiple CPUs see same thing. Whatever that construct is. Okay. So now this stuff goes in here. And thread priv gets some stuff as well. So that goes in here. And we also need our frame samples U00 here. Okay. Surely a bunch of stuff stopped compiling there because we just juggled a bunch of stuff. So const frame equals. So here. Oh, this is fine. We just have to say, hey, don't use this shit. Here, this needs to go under shared. Same here. Everything here needs to go under shared. Samples provided now needs to go under thread priv here, and as well over here. Error is ignored on main 137. So we'll just throw a little try on this guy. No frame key mutex and audio player, so it's at 104. This also needs shared here and here and here. And I think we're chilling, maybe. Okay, so he now gets a frame, and we need to handle these cases. So we're gonna have to look at frame count is dual channel. So this is going to be the same thing as like the number of samples in our decoder audio frame. Num samples here. Well, what is this actually? It seems like number of samples is actually kind of implied by the channel data, right? If we have like a list of things, then the number of samples is just the size of the list. So let's just double check that that's true. Data len is the line size. So I guess here, I'm just going to make sure that we understand this correctly, and we're going to say that the number of samples should be the data len times the size of the data element. So in this case, it's a float 32, so times 4. If I understand this correct, this should always be true. Then, on that side, on this side, the audio thread side, we should be able to say that for 0 frame count. Okay, so this still makes sense. We're saying we have some amount of output that we want. let's fill it. We will then try to pop a frame, or we'll try to peek a frame. We should call this, shit. Is there a way to, can we peek stuff in here? There's read item. Peek item. Nice. Okay. Can I push stuff back onto the end? Not really. Not really. This kind of sucks. This sucks. Okay, here's what we're going to do. We are going to lock the mutex for this whole section. And just say that at least on push, the contention should be still pretty low, because on push, they're not doing very much. They're just writing one item. Then we will say const frame is equal to frame q peek item, okay? Where peek item, I just want like the last thing. Item at offset. Is offset from the end? Self head plus offset. So it's a self buff len. Offset is less than self.count. So this is going to be self shared frame q count -1, I guess. Okay, now this is not going to be per frame count, actually. This is just going to be a while loop. And here we're going to say var output frames is equal to 0. Sure. Now we can look at the last frame and try to copy in some amount of data from it. So this is where the thread priv frame samples used comes into play. So we may have consumed some amount of this frame in the previous iteration. And so we're going to look at this and look at the length of the frame. And we can copy some amount of frames in there. So we can go to the frame for each of the items, for each channel. We have to interlace this stuff. So this is actually going to be for, right, we're going to index these guys from self, thread, priv, frame samples used, to frame num samples. Yes. For each sample, we are going to copy that to the output. So this is just going to be a copy-paste from frame channel data. We're going to go each channel for each channel. For frame channel data here. We're going to say God damn. It's hard. It's hard. My head hurts. So this is going to be like something and an index, j, we'll call it here. Output I times something plus j is equal to f. What is f here? What is my channel data? It's const u8. So we have to actually copy like directly to here. We were writing like as floats. I guess what we have in here could be like it's gonna be, if the stuff was floats, we're gonna have 4 bytes that are packed as u8s and then use them as a float, which kind of means that we need to stood debug assert that the frame info format is equal to float 32. Just for now. Then we can assume that the sample size is equal to 4. And we are going to copy stuff into the output. So it's like output I output frames times the number of channels times the sample size plus j times sample size. We're going to copy something in here. Like this. Jesus. So we're gonna put some stuff into the output based off of oh my god, my head, my poor little head. My poor little stupid little head. This is gonna be a while loop because we need to increment by more than one at a time. So this is gonna be while this is less than this. This is going to be incremented by the sample size. Yes. Then for each channel, we are going to do this memcopy. And let's maybe split out something. So output start is equal to this whole thing. And maybe we'll factor out the sample size like this. Const output end is equal to output start plus sample size. That makes sense. Memcopy from output start to output end. And we're copying from our frame. So we have frame channel data at our frame index. So this is items j. Gross. 2 times j times sample size. Yeah. Const input start is this, I guess, times sample size. Okay. Input end is input start plus sample size. This is actually the same for every single channel, so this can go up here. And then we copy from input start to input end. That might make sense. Then, at the end of all of this, we have to reset the number of frames used. Output frames is not used. Output F is not used. Output frames. What is this? Output start is equal to... Output start is equal to output frames. So this should be here. And then here we increment output frames. Output bytes, we'll call it. Okay. Output bytes. So I guess it's just this. Output start is equal to output bytes. The number of bytes that we've output plus the sample size. Okay. Okay. And this doesn't come from items. This is from F, sorry. Here. And I don't think we need this iterator here. And I guess we don't need this I here. And let's see. So we look at a frame. We say, hey, how much of this frame have we already used? And then while it's less than the number of samples in the frame, then we try to inject into the output. Now we also need another exit condition here. If output bytes plus sample size is greater than or equal to the amount of stuff that we wanted to put in, we break out of this loop. Okay. Okay. Now, we need to do this some amount of times until the frame count is finished. So this is actually all, which is already this loop. So this is while output bytes is less than frame count. So here we break out early. Here we do the same condition. This we need to set to a usize. And then the only thing we need to do here is after this loop, we need to say if the frame samples used is equal to the number of samples, we will pop the last item in the queue. So frame queue discard 1. And then we reset the samples used. Oopsies. And then, okay, maybe that's fine. Maybe that's fine. We'll actually have to cast this thing, so we'll say const output b is a pointer to some U8 data. And then everywhere when we're writing to the output here, this is output b like this. Okay, maybe. I mean, it might work. I'm very much not sure. I guess I will turn down this audio just in case in OBS. I will still get absolutely railed. If it's fucked, but okay. Thank God we just crashed instead of it being absolutely broken. So frame queue dot count -1 at 135. Okay, so here we need to say if our frame queue has nothing in it, so if this is a 0, we just return. Okay, we got a little farther. We hit a unreachable at here. So it looks like our understanding of number of samples in a frame might not have been right. So can we maybe look at those things? So I thought the number of samples would be, I thought that this would be, we have like, 100 floats in our buffer, and so that's 400 bytes. Oh, maybe this should be over 4. Oops, not times 4. Oopsies. Okay. Still not right. So let's maybe, GDB. And he's going to tell us. So we can look at, where are we? We are at frame 7. The number of samples, 1024. Data len, 8192. Oh, because the data length is multiplied by the number of channels, I guess? Surprising. Let's look at the docs there again. AV frame. So here, for audio, only line size 0 may be set. For planar audio, each channel plane must be the same size. Can we look at, like, is Zig strongly typed? I don't know. I don't know what, like, what does that even mean? I know strong types are, like, a thing. Strongly typed, I assume, means that you don't, like, not duck typed. So I assume yes, but I don't actually know what this means. No precise technical definition. Sick. But yeah, you can't, like, I mean, you can't change the type of a variable, which I assume is what it means. Okay, so something about this doesn't make sense. Let's look at what else is in here. Data. So can we, like, list and look at frame extended data 1. So that has valid data in it. 2, 3, 4, those are all null pointers. So 0 and 1 are both set, which makes sense. We have 2 channels of data. But he's saying that the data size is 8194 for 1024 samples. And that doesn't make sense to me. Because I would think that if we have 1024 samples and they're 32-bit floats, that's 4 bytes per float. And so the data size should be 1024. But I guess what this is kind of saying is that we should divide the data length by num channels. That's kind of what's, like, being implied here. So now that assertion should pass. And I heard some absolute garbage in my ears, but it wasn't too bad. So I'll play it again at full volume. Listen to that. So clearly I'm doing something wrong. Let's think about this. Let's think about this. So how can we debug this? How can we debug? I guess it's just printf debugging makes the most sense here. And I don't know where to start, to be honest. I guess we start at the first sample. I guess we just break... Actually, I guess we can just breakpoint here and just see what the fuck happened. Okay. So, frame count, 900. We can look at the thread priv frame samples used, and we have 452. P self frame num samples, 1024. So, what the fuck is going on there? Our frame samples used is less than both the amount of frames that we asked for and the number, like, it's smaller than the frame size and what was asked for. So we're doing something fucking stupid here. So frame samples used, where is this getting incremented? Here. So we're saying, hey, we're copying, oh, this should be 1 maybe? Not the sample size, because we're multiplying by the sample size down here. Let's see if that makes more sense. Okay, and then we need to break at this line. Okay, so let's look at this again. So let's look at this, 113. And look at this, 1024. And so both of those don't really make sense. And the output bytes, we output 904 bytes. We had 1024 available to us. We've used 113. Like, none of these numbers are adding up. None of these numbers are adding up. Unless my breakpoint's ending up down here. No, even then, that should be fine. Okay. So on each iteration of these things, what did we say num samples was again? There should be... we should have it here, actually. 1024. Okay, we have 1024 samples in the frame. We should use... I think it was 900 of them. That's what we should do on the first iteration. So let's look closely. This is wrong. This condition is just fucking wrong. It's output bytes. This first of all says plus sample size, which is fucking stupid. This should be times. This should also be times sample size. And I think this should also be times num channels, to be honest. Which comes from the device. Where's like num channels? It's not anywhere. Yeah, because the number of bytes is, yeah, per channel, per sample size. Yeah. So it's a device. Any book or resource you recommend for learning how a video editor work? I mean, I'm just guessing. So I guess my recommendation is to guess. I did like zero research, to be honest. I was just like, this makes sense to me, right? I guess I Googled how to decode video, FFmpeg, but I kind of already knew FFmpeg existed. So that's not very helpful, but just guess. Sorry, I wish I could. So I know that there's like people that learn really well from books. I've only read one programming book ever that I thought was useful. I mean, I guess like modern C++ was useful because like C++ is fucked and you need to know all the things that are fucked about it. But like the only time that I've read a book on like how to implement something was this USB book, USB operating systems book. This is the only book I've ever read where I was like, holy shit, this is actually useful. Because I just couldn't find the information Googling effectively. But usually, for the vast majority of everything, I just find that like you start the problem and you just type into Google, how do I start? And then you figure it out. But yeah, for when I was trying to implement USB for iOS, I was like, oh, this is too hard. Because I would like read the spec and it was just like the spec is just full of like trash. And you're like, I just want like, could somebody just tell me what it's supposed to do in like human dumb words? Anyways, so I know like some people like books and like some people really prefer books and courses, but I'm more of a like just start and you'll hit a wall and then you'll Google that wall and you'll just keep going. Usually. Sometimes it doesn't work, but the vast majority of times it does. Do you also search open source code to see how they use that library? Not a lot. I guess I've been looking at FFplay a little bit, which is like integrated into FFmpeg. I do look at source code, I guess. Like, I guess the other day we got stuck on YUV color conversion. We ended up in the SDL source code. So I guess. Yeah. I guess. What I was looking for, I was trying to figure out what's in this thing. MA device. Which is in miniaudio.h. Are you going to do software-only rendering? Well, we're hardware rendering with OpenGL. We're software decoding, but I guess you could theoretically software or hardware decode as well. I just don't. I'm probably not going to do that if it's not expensive enough. Or I guess render. Yeah, renders to the screen. In terms of like re-encoding, I'm probably just gonna like pass timestamps to FFmpeg and be like, please try to keep as much data as you can exactly how you found it. But I don't know. I haven't got there yet. I'm not much of a planner. I'm more of a just fucking start and then figure out what happened, figure it out later kind of guy. Okay, so this is in device, playback, no, channels. Sample size isn't here. Where did sample size go? This is up here. So we'll just kind of, I guess we'll do this. And just note sample size. used. I guess maybe we could assert on the device sample size instead. So here we can just assert that the format is that the device playback format is equal to CMA format F32 or something. MA format, yeah, F32. Nice, 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 nice. And then down here, this condition has to be mirrored here as well. Let's try that, see if that's any better. Still no bueno. Still no bueno. Although, maybe this assert is... That assert's kind of indicating something odd. That, like, we have, like, so much audio that we haven't used yet. That's kind of what this is indicating. Also, the fact that I'm only hearing this out of one ear, I think. Yeah, I don't hear any buzzing in my right ear, so there's something fucked going on there as well. Why is my disc just fucked? Like, why am I... Like, hello? What's going on here? It's weird. I don't know why this terminal's, like, so fucking frozen. That's annoying. Annoying, but... I guess we just restart Nix, or our Nix shell and get going. I'm currently having to read ICCM specifications because I'm making a minimal window manager and want some other features, but I'm only doing that because I hit by a wall. Oh, dude, that's fun. I've been meaning to look into that a little bit because I know that, like, understanding how, like, a Wayland server works seems kind of interesting. Understanding how an X server works seems kind of interesting. I'm kind of assuming that once you get your, like, I'm assuming that you have, like, an OpenGL renderer for your server, or a Vulkan. You just have, like, some, like, way to draw shit onto the screen. I don't know where you get the context from. Maybe you ask, like, for an EGL context or something. Oh, X server does everything. Oh, I see. I was thinking on the Wayland side, you are the server, but you're writing your desktop display manager starts X. X calls your process, and you say, hey, X process, I'm the window manager, and could you put a window over here, please? Type shit. Let's go. It's still cool. Super cool. Interesting. He's, like, actually consistently getting stuck there. That's really interesting. Oh, wow. What the fuck? And then my whole thing is, like, fucking slowing down. So can I, like, ps aux grep video? And then kill -9. Oh, there, he finally got out. Is it because I'm core dumping and it's like that's just killing my memory? Could be. I don't understand why it's like so bad. Let's try running it under DB and see if it's like equally shit. Okay, can we look at audio player here and look at his what do we have in there? Shared, frame pool, frame queue. So what's going on here? Frame queue, he should only ever have like 10 frames allocated, so that's not that much. It looks like he has 10 frames ready to go. Something feels wrong with my computer, to be honest. I don't see anything, but it feels like disk is railed and just like stuff isn't working correctly. But I guess maybe not. I guess we'll just keep going and see what happens. Okay, maybe here what we'll do is we will std debug print every time we discard a frame. Okay, we'll start there. And then down here, we will maybe write down we'll write down discarding frame. Discarding frame, we'll say how many with this many samples. And then we'll write down frame num samples. And then here we will maybe say use this many samples from frame. So this will be frame samples used, or this is a self thread priv num sample frame samples used. And then here maybe we'll even throw up here audio thread requesting this many frames. And we'll say frame count here. And I guess we need a new line here, or else it's going to get mad. And we'll zig build and run it, but in GDB to avoid the core dump bullshit. And let's just kind of see if that tells us anything. So used 150 samples from frame, but he's requesting 900 frames, and we only used 30. So like we're doing something fucking wrong there again. So okay. I guess it's this condition is exiting early. Because number of channels is duplicated by the frame count. What is output bytes plus equals sample size here? Okay. Oh! I've got this on the wrong side. Output bytes times sample size. So, this is output bytes over sample size over the number of channels. Yeah, I just had it backwards. I think. That sounds right. So the number, what was it? Number of channels? Oh, it's down here somewhere. Because the output bytes is going to be multiplied by the sample size, multiplied by the number of channels, but we want to check the number of frames that we use is also related to number of channels. Yeah. I didn't explain that well because it's not solidified in my head very well, but I'm pretty sure that's better. So now we used 1024 samples from the frame, used 901 samples from the frame. Okay, and then let's see, this is still a little odd. So use 901 samples from frame seems a little off. Used. Oh, but that's okay because we increment this unconditionally. So here we say, hey, if this is less than num samples, increment it. So if they ask for 900, we're on 901. That doesn't feel right. Does not feel right. Let's try running it again. I need to infer a little more. So the math gets kind of tricky here because we're working through frames with 1024 samples, but the audio thread's only requesting 900. So let's see. I guess maybe we write down how many we used this time around as well. So maybe we'll say down here, we'll say that we wrote how many bytes. Wrote this many bytes, which is this many samples. And this will be output bytes. And then we will do output bytes divided by sample size, divided by device playback num channels. Then hopefully that will give us something interesting. No field named num channels, it's just channels, isn't it? Isn't it? Okay, so wrote 70208 bytes, which is 901 samples. So we keep going one too many, which seems like a problem. So where's that 901 coming from? While this is less than the frame count, we do this, and then we say, well, this is less than that, and we say if this is greater than or equal to frame count. We probably have to break out here with an equals. Maybe? This code base is a good argument for comments. Well, I think that what will end up happening is hopefully I'm more likely to factor stuff out, but we'll see. So here, we used 900 samples from the frame and wrote 7,200 bytes. Audio threads requesting 900 frames, used 1024 samples per frame, discarding. And then where is this backtrace coming from? This is coming from... Is this even in our thread? I don't... Oh, it is at frame 6. Ooh. So here we're actually crashing because we need to do this check actually every iteration of the loop. Let's try that. Oh! Okay! That's not good, but it's not that bad. That's almost it, right? It's beautiful. Ear bleed. Yeah, I mean, it's not... We've done better, for sure. But let's listen to the real one. Okay. I think that the only problem is that we're not buffering the audio. Okay, so when the river comes in, we should hear the river. So let's see if we can hear the river at all. Because if we can, then it's just buffering. Oh, okay, the bird's coming at the right time. So I'm pretty sure it is just that we're buffering. So what we'll do here, maybe... Let's think. We just need to feed more audio in. So maybe what we'll do for now is we'll say, fuck you, video. Right, we'll just fuck video, and we'll just see if we can get a clean thing if we just try to rip audio as fast as we can. I think that makes sense. Okay. So that would be... let's replace this get next video frame with, I guess we'll just call this, like... maybe we didn't even replace this. How do I want to do this? While should update frame, we try to get the next frame. Fuck all this shit, right? Actually, fuck everything. We'll just kind of like do a different loop. So we'll do like if true return here. And then we'll do a while loop up here. And we will just try as hard as we can to fill up our audio buffer. So we'll do this. Dun, 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 dun. Yeah, sure. We'll just fucking halt loop if we run out of frames. Fuck it. I don't care. This is scratch code. If it's video, we do nothing. I guess we probably have to de-init the thing. Oh, fuck. In our callback thread, we definitely have to free the thing that we popped off the thread. That's very important. There we go. That's important. Or else we will just run out of memory. This needs to come in as a star. And then here we say, if the number of frames needed is greater than 0, or is equal to 0, we continue before we get a frame. Then we should just fucking hot loop, but that's okay. And let's just see if we like hear something pleasant to our ears. Read item. Oh, fine. Var frame is equal to read item. Fine, if you're gonna be like that. You're gonna be like that. Okay. Then this guy needs a bar frame here, I guess, for him to be mutable. I'm actually not sure where the latency is coming from. I wonder if it really is the mutex lock and unlock. We could maybe log the amount of time that this callback is taking. Well, let's actually get rid of the prints as well. Maybe that's causing some problems. Could GDB be slowing it down? Yeah, I guess that's also a possibility. And also the, is there any allocations happening in this thread? I don't think so. But we should be careful of that as well. Why is it still... Man, it is... I don't understand how it's so close. Are you looking far enough ahead? I mean, we have 10 frames, like, and I guess maybe we should write down if we'll write down here. Ran out of frames. I don't think that's happening. Oh, we did. See, we only run out of frames at the beginning. So that can't be it. Instead of defer increment samples used, move to end of block. I don't see how that could make a difference. Right? Like... Yeah, because it's not like there's, like, early returns there that should be causing problems. What was interesting, too, was that the bird, it seemed like it was, like, cawing at the right time. And so why that feels weird to me is that it feels like we weren't drifting by that much. So, like, then where's the crackling coming from? You know? We could try... I'm just gonna bump the frame queue size. I don't think it should matter because... That'd prevent getting the extra 901 instead of 900. I don't think so, because this defer is only happening after the exit condition. I don't think... Are we ending up at 901? Oh, you think maybe every once in a while we're skipping a frame. So, okay, let's look at, like, the edge case here. Say num samples in the frame is... I think you've already fixed the 901. I also think I already fixed the 901. But I'm not 100% sure. So let's look at, like, the edge case, the base case here. Say we have one sample and we're starting at 0. We come in here and we say we used 1 frame at the end of this block. And then we come back here and we have 1 is not less than 1, and so we break out. So at the end of this, frame samples used should equal the number of samples in the frame if we ran out. Otherwise, say that this is 2. We go through once, this gets incremented to 1, and we hit this breakpoint, and we break out, it's still 1. And we still have 1 left in this number sample. So I think that that's okay. Logically, that feels like it makes sense to me. Okay, let's try. I want to try discarding the right ear. And because if that works, then we at least know that we are aligning our data correctly. So let's do if j is greater than 0, break. So if we did this right, then only one ear should get sound. Oh no, that's not true. It's it should be this. Okay, so I hear nothing in my right ear, and I hear something in my left ear, which to me indicates that this is, at the very least, this part is right. Hand wavy. Let's do something crazy. Like, try to fuck this up in some way. So input end is... So input start, we say, hey, we use this many samples, and they are of this size. Here we're handling the times number of channels, and here we're incrementing by sample size. And then here we're saying we want to copy sample size stuff to output bytes. So I actually don't... Say we drop every other thing. We should start to hear something that's a lot more fucked up. So we can say here, if j equals 0, and frame self thread priv frame samples used %2 is also equals 0. So here, if we drop every other sample, we should start to hear something that's like really stuttery, only in the left ear. That's actually not that bad. What if we try to, like, over 4? Over 8? Like, it seems like... I'm trying to figure out, like, the scale of how bad this is. Oh, interesting. That's actually kind of funny. So by doing that, we're actually kind of doing a, like, some form of audio filter by mistake, because it's just dropping samples. Can we assert here? This was indicating that we always wrote the amount of samples that it asked for, right? I think. Wrote 7,200 bytes, 900 samples every time. I guess. Okay, hold on. Let's git add -u, git status, make sure everything's good. Git commit -m, audio almost there. And can we go back to our sine wave and see how many bytes that we write there? Right? Let's just go like here and go to our audio stuff, and in our callback, can we maybe say that we wrote some amount? So we can say self samples provided and then we can write stood debug print gave this many wrote this many bytes, this many samples. Okay, and this is samples provided minus start samples provided. And this is all multiplied by 4. And then this is self samples provided minus start samples provided. So now we should hear our little sine wave. No? Are we not running the audio player? Oh, we'll run audio test instead, I guess. Wrote. Okay, it's doing something wrong there. What the fuck? What the fuck? Wrote this many bytes, samples provided minus start samples provided. Oh, oops. Oopsies. Oopsies. Okay. So in this case, we're actually writing half. We're writing half the amount that we're writing now. Oh, but this is incrementing. Oh no, wait. But this is multiplied by 2 channels. Okay. That lines up. That lines up. Let's just double check that makes sense. So we're saying 2 channels times the size of a float times 900 frames. 2 times 4 times 900. Yeah. Okay, so I think that means that we understand that correctly, at the very least. Right, like this, the fact that we're writing 7,200 bytes is like perfect. And so then the crackle must be coming from somewhere. Could be rounding issues. You're worried about this stuff. Output bytes should only ever be incremented by this amount, though. But you're right that we should maybe like std debug assert that output bytes percent sample size times the number of channels is 0, just to double check. I'm pretty sure that should always be true, but it's worth checking because clearly I don't understand the bug, right? Because if I did understand the bug, then it wouldn't be happening. But yeah, that assertion's not getting hit. So it feels like we're copying the right amount in, and this we confirmed that the channels were correct. When we discard one channel, it only sounds in one ear. I wonder if we can like look at the data and see. Well, we log output bytes as well. Output bytes is always equal to 7,200, which is perfect, right? Because 7,200 into this is like the number of frames it asked for. So it's not like we're like forgetting to write data. We could maybe look at what we wrote and see if there's like holes in it. Like maybe we GDB this guy. We break in the audio callback. And maybe we can like print. What are our inputs here? P output B. Yeah. And then we want to print 7,200 bytes of this stuff. Output B. Oh, it's a star output B at 7,200, I think. That's not helpful. Can I say print it as hex? And then can I say print it from output B plus 7,000 at 200? Like, give me like the last 200 things. Yeah, I don't see, it doesn't look like we're like forgetting to write some of it. Right, if I put like 300 here, or 7,100 at 200, right, then all of a sudden when we get past the end, we see a bunch of zeros, which makes sense. Right, so like the fact that here we're seeing it get like real data right up to the end feels good. Does the audio do something similar to the video where it has a stride and is padded with zeros? I don't know why it would though. We could look there, yeah. I mean, we asserted that the line size matched up with what we expected though. Right, like in our decoder side, we did check somewhere that the number of samples that it's saying that we got is the same as the data length. So those things should be interchangeable. Let's maybe look at the frame again. Let's just like make sure that we're not missing anything obvious. Or maybe let's look at FF play and double check that it's kind of doing something that's similar to what we're doing. FFmpeg GitHub. And then in their FFmpeg repo, we can search for ffplay-c and look for its audio. So, AV codec receive frame. He is doing some sort of. Well, I wonder what this is. That's a good point. We should look at the PTS of the frame. So here, can we look at the std debug print? What is this guy? Frame PTS? Maybe there's something wrong there. Maybe. No, it doesn't seem like it's doing anything sketchy. It is pretty steadily incrementing by 1024. So that's in like samples. Possible to write output B data into a file and play it with a different player to rule out mini audio misconfiguration. That doesn't seem crazy. We would have to figure out how to play raw audio. Maybe it's channel packing, LLL versus RRR. No, it's definitely split by channel because we have the channel data is getting injected per number of channels. They're already split. And the fact that we're getting like something that sounds kind of sane in both ears kind of indicates that's true. But I am kind of curious if there's like, if we just like really fucked our shit up, like only copied half the data ever, I wonder how bad it would sound. I wonder if we can ask it to ask for more data or something. Because there is something funny about that line size being double what I expected. Number of audio samples per channel described by this frame. And then line size, like this line size was double what I expect. For planar audio, each channel plane must be the same size. Let's look at what they do for line size in here. MB samples. They actually might not use line size. So we could try, just out of curiosity, using MB samples instead in our decoder. So we have data len here comes from line size over MB channels. And then maybe we should just assert here. Oh, we do assert that that's the same thing. Number of samples is the data len over 4. Yeah. So that seems fine. Seems fine. Maybe is it possible we have mismatched sample rates? Like, what if it lies about the sample rate, or the sample rate changes? I wonder. What do they do in FF play for the samples? frame sample rate. Frame sample rate. So here they're claiming that you have like frame sample rate. No. Oh, yes. Int cast. And then can we just log the frame sample rate? So can we look at maybe in our audio zig, we will std debug print the frame sample rate and the device sample rate. And this will come from frames info sample rate, and the device sample rate will come from device playback sample rate. Maybe that's not quite right. Mini audio.h. Sample rate. Still no. Playback. Was it playback? Here. Oh, it's under the device, not the playback. Okay, the sample rates are the same. Mini audio docs. Multi-channel audio is always interleaved. I think at line 366 we give it planar. I think we are giving it interleaved by doing this. I think this is making interleaved. And we did confirm that if we drop one ear here, that it does drop one ear in the output. I think if we misunderstand what mini audio wants, the small buffer size might make it sound like almost correct. Yeah, I am curious about that. I wonder what happens. Let's just do something like fucking crazy. And let's just say like, what happens if we do like frame count is equal to frame count in over 2, right? Like what happens if we just give it half of what it wants? Oh, we don't need to run this in GB. Okay, and what if we give it double what it wants? So that clearly goes out of bounds. And like if we divide by 2, yeah, it gets like it goes half as slow or half as fast and feels more crackly. What does it sound like normally again? Let's see how long is this callback taking. Maybe we're like blocking up the audio thread. So here we can say try stood time instant now. Const end is equal to and then at the end we say defer. Const end is equal to this. I guess we'll just write start here so that it has like a value. Then we say and since start, say stood debug print took this many and in nanoseconds. And if this is a really big number, then that's like kind of a clue that we have done something wrong. Callback start, we'll call it, because it's complaining about shadowing. I don't know what's shadowing what, but god damn it. We'll make this nullable, I guess. And then this guy has to be and is expected semicolon after statement. I feel like there is one there. And then we'll like just assume that everybody's happy here. Just so that it doesn't fucking fail. Error unsupported time instant. Oops. It should be catch unreachable, maybe. Maybe that's how we get out of this bullshit. Then this doesn't have to be nullable, and then this can just be like this, maybe. Time instant ignored. This should also just be unreachable. "75 microseconds? That shouldn't be enough to cause problems. That shouldn't be enough to cause problems. Are we undersampling? It does kind of feel like it, huh? It does feel like it. PW top reporting any errors. Is that something that can happen? So we can do something like run this thing. PW top. Oh my god. There's an error column. Oh yeah. And they're all from OBS. It's kind of funny. Is my thing in here? Video editor. Yeah, no errors here. Oh, we lost the video, so we actually can't tell if it's we can't tell if we're synced up. Him. So let's. I want to look at the decoder side again. So we're assuming data len over 4 is the number of samples because data len is the line size, which means that if we're copying what happens if we were to like, maybe we're like doing something stupid with memory? What if we like accidentally free this shit when we're not supposed to? Right? Like, what if we just never like, right? Like, let's just prevent anybody from ever freeing frames just to see. I doubt that's it, but yeah, not helping. Not helping. Can we ask for more buffering in our device just out of curiosity? Although when we were pushing in a sine wave, it was totally fine. So I don't really feel like we were like having trouble filling it up in time. Did PW top say format S32? It did kind of say that, huh? I did notice that as well. But I kind of assumed that was there was some sort of like internal conversion happening from the pulse interface to PW top, but you're right that it could be untrue. It's possible that we fucked that up in some way. So it is worth looking at. You are right. I did notice that. I discarded it. So let's look at device. Oh god. Set print pretty. And set pagination off. There you go. Okay. So where would it say its format? Format. Format for playback 5. Playback format 5. So we can look at... Oh, we do check that it is MA format 32, but I wonder if we've made a mistake there. MA format. Like, where is this thing defined? Enum MA struct MA format. Typedef MA format. They are saying that you can pass this directly into the playback thing, so it does seem like it should be right. Yeah, here. I mean, we could try. Like, I'm sure that if we, like, heavily misconfigure this, right, like, let's just, like, really fuck our shit up. Oh, God! Ow! Ow, 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 ow. Ow, yeah, 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 yeah. Okay, I'm gonna mute my playback, mute you guys, and try that again. I just want to look and see what PW top says. Zig, build, and run. And then over here, I want to look at PW top. And here we should see our something somewhere. Video editor, it does still say S32LE. We're all deaf now, problem solved. And here we go back from S32 to F32. Purple Elf, thanks for the raid. What's up, everybody? What is up? Okay. You guys want to hear, do you guys want your ears to bleed? Check this shit out. Hopefully it's not too bad, right? Like, okay, so this is what we're working on, is we've been trying to get audio working in our video player. We've blacked out the video right now to just focus on the audio right now. And you can see here, it's clearly crackling, but we're kind of close. Hope you guys had a good stream over there. We are working with mini audio and pulse audio, but through pulse audio, we're getting into Pipewire. Audio, fun, and we're just struggling. We've been like slowly trying to debug what the hell is going on. We haven't really got anywhere yet. No way you building a video editor. Yes, right. Okay, so for context, you guys, we are working on a video editor where the idea is that we want to be able to edit things quickly. And so the goal is I want like something that's lets me select chunks of text. I want to be able to auto-generate a script for a Twitch VOD, and I want the script to be tied to the timeline. So the idea is that I want to be able to select text and say, this is a chunk of something that I want in like a YouTube video, this chunk is not. And then I'm hoping that like being able to cut down video that way will be way faster. But before we do that, we have to be able to get some sound, you know? We have to have a player that works before we can have an editor that works. So we're working our way up. Look. Thanks for the sub. I know that that's not how I'm supposed to say it, but butchering it's more fun than trying to decipher that chunk of letters and numbers. Okay. So we think we've debugged so far. If we play only one ear, we get only one ear. That's a good sign. We've made sure that if we play half the data, it goes half as fast. Also a good sign. We've confirmed that the sample rate, at least like the data that FFmpeg is reporting to us, it feels about right. Like we have some assertions around that like the size matches up with the number of samples times the number of channels. So those two things seem to be lining up. And so I don't really know what the next thing to look at is. It feels like it feels like we're not giving it enough data. That's like just the way, like it feels like choppy to me, right? Like when we play this back, it's just like every small amount of time, we're just not giving it what it needs. Yeah, I don't really care that it's not responding. I intentionally fucking paused it. Screw you, KDE. It's weird because my prints say the correct sample rate. Yeah, there's something that's just like not. Could it be something around our like handling of if the frame isn't big enough? I wonder if we can ask it to ask for like more data at a time. That would be kind of nice if we could say, hey, mini audio, please ask for like more. And I think that we did see that there was like some like buffering parameters to pass in. Is this Zig you're using? Yeah, for sure. For sure. Yeah, so let's see if we can configure mini audio to ask for more data. Oh, we also confirmed that the callback is only taking like 75 microseconds, which shouldn't be enough to like hang the callback thread or anything. We're never running out of data. We've confirmed that like if we were feeding the audio thread too slowly, you could imagine that this would also happen, right? Because you'd be like, oh, I need to play some data, and we'd be like, nope, get fucked. So, okay, yeah, let's try configuring MIDI audio to buffer more. Oh, wait, hold on. Let's also try just switching the fucking backend. Hold on. Yeah. We can force it to use jack instead of pulse audio, and that's like a really good bisection. Where both jack and pulse audio will use... These are like interfaces for Linux audio. Linux audio has gone through like this like hellhole of different APIs. They've had like ALSA, OSS, pulse audio, Pipewire, jack. I've encountered all of those in the time since I've started using Linux. So what's happening right now is there's like jack, ALSA, and OSS were all like lower level APIs that had exclusive locks over your speakers, if I remember correctly. Then Pulse Audio came in, and he like was like a nice little like high level thing where you could use like applications and stuff. Wow. And then Pipewire came in to replace Pulse Audio and has also Pulse Audio jack interfaces on top. So my computer is using Pipewire, and if I say to Mini Audio, hey, could you please use jack, it will still use Pipewire but through a different interface, which might give us some clues. So let's try that. I think that somewhere I can specify the backend. When I create my context, I think that I should be able to say, please be jack. So I think it's in MA context init. Backend is the first thing, and const MA backend comes from MA backend here. So here we can say CMA backend jack. And then let's fuck GDB. We ball. And he failed to initialize context, which is kind of interesting. Can we look at maybe... That's interesting. Because I think that we have all the right parameters for jack. We were using jack the other day and it was working like okay. Can we like maybe print out where this is coming from? So 192 failed to initialize context. Whoa. What's happening here? Because I'm pretty sure that this was working the other day. I wonder if it's because I have libpulse available. I added this the other day, so let's try getting rid of that and see what happens. And then I think we can compile mini audio with debug on, and we can see we get a little bit of extra info on what it's doing. I believe jack is kind of mid-level, OS is the old low-level, also is the old new low-level, and Pipewire Pulse Audio are the modern high-level ones. I think it's something like that, yeah. Okay, where's the debug flag? MA debug output. So let's just slap this scopes. Slap this here. And let's see if we get something. Failed to initialize context. Where's my debug output? Where's my debug output? Last time we were getting so many nice little logs. We were getting so many logs. What changed? Yeah, I don't understand what's different today than from the other day when it was working okay. Do I have, like, stuff in my build script like an idiot? I'm patching mini audio because of the Zig compiler bugs. We're including this impl. I guess maybe it's because I'm trying to initialize the context manually. We weren't doing that the other day. So we could try kind of like nuking this stuff and passing in null here and see what happens. Is it getting recompiled? It does feel like maybe not, right? Does feel like maybe not. And then can we maybe comment this out and write this is undefined? And then I'm just trying to figure out, like, how do I get everything in a compiling state just to debug. There we go. Okay, so here we go. Now we're getting into trying to run Jack. And here we're trying to format something at this print, and we're trying to print undefined, right? So let's get rid of that print statement because it's trying to log some undefined memory, which doesn't shock me that that's crashing it. It's, you know, it is what it is. This is what... Am I high or is that better? I can't tell if I'm just... That's fucking fine, right? Right? I'm not just like... I'm just corrupted my own memory? Okay, so that's a real strong indication that Pulse Audio was doing something shitty. So I wonder if it's like maybe compiling without optimizations in MIDI audio was fucking us. Oh, it's so good. I'm so happy. Can we let's bring video back. Let's bring video back. I think I prefer the crackling version. It is kind of more on brand, eh? Okay, so we did update this loop to just try to like feed the audio thread as much as it fucking could. Let's see if we only feed when we have video frames. If still sounds okay. No, we're back to crackling here. But that's because we're just not feeding enough. So we have to buffer the video frames as well. Yeah. But if we just try to feed it as fast as we fucking can. I'm happy with that. I'm happy with that for now. Okay, let's think about this. What do I want to do next? Oh, it's so fucking sick, man. Okay, so I think what I'm gonna do is I might look at this off stream. I think that I've kind of bisected a good chunk here where we have at least a way to get audio out with Jack. I don't know what the issue is with Pulse. Maybe the buffering was there. Although here the buffering is, oh yeah, it is a little more now, huh? We're writing 1024 samples instead of 900, and 1024 is an even multiple of the frame buffer size. So there is something that could be going on there where, like, if we're handling that poorly, it might not be great. But yeah, I think I'll think about this a little more off stream, and we'll see. Probably what's next is I want to implement seeking and maybe some form of eventually we'll have to get into like the subtitle stuff, but we'll see. I'll have to think about what I want to do before tomorrow. But thanks for watching, guys. If you like what you saw, I stream most days at around 2 o'clock Pacific time for around 2 hours. We went a little long today because I was angry. But yeah, we stream most days, and if you want to see what else we have on YouTube. All the VODs are up, organized by project. There's a GitHub link in the Twitch description where we have all of the source code for all of those projects, so if you want to check those things out, they're there. You'll see things like terminal emulator, neural network, virtual file system, QR code decoder, zlib, implementation, video editor, right? Operating system, whatever the fuck we feel like. It trends towards low level, but we're having fun. We're having fun. Yeah, if you're watching on Twitch, there should be a YouTube link in the Twitch description, Twitch link in the YouTube description if you want to swing by and say hi because you happen to be online. That would be cool. If not, no big deals. Yeah, YouTube viewers, I guess goodbye, and Twitch viewers, let's figure out who to raid. Like, subscribe, Twitch Prime, you know, all that good